In this video, we will do a probability question involving an asymmetric tree diagram. So the question says that Paige is practicing free throws. She makes her first free throw 75% of the time. After that, whenever she makes a free throw, she will make the next one 80% of the time. But when she misses, she will miss the next one 55% of the time. Paige shoots until she makes 2 in a row, or shoots 3 free throws. Given that she makes at least 1, what is the probability that she doesn't take the 3rd free throw? And round to 3 decimal places. So I want to begin this question by giving you the opportunity to try it. So pause video for 4 minutes to try this question. 4, 3, 2, 1. Pause the video and try this one for about 4 minutes. Alrighty, so hopefully you've done that. Hopefully you tried it for about 4 minutes. Let's talk about it together now. So let's begin by labeling some of these events. So I'm going to let M be the event that she makes a free throw, and I'm going to let D be the event that she doesn't. That she doesn't make a free throw, or that she misses a free throw. Okay, so in that context, we want to find the probability. Let's see. It says given that she makes at least 1, so I know it's going to be a conditional probability. Given that she makes at least 1, it asks what is the probability that she doesn't take the 3rd. So the probability that she doesn't take that 3rd free throw, given that she makes at least 1. Okay, so let's see if we can handle this with a tree diagram. Alrighty, so I'm going to zoom out a little bit just so I can see the numbers as I draw the tree diagram. Okay, so let's draw a section for where we begin. And in this tree diagram, we're actually going to have 3 stages, because we'll have her first free throw, her second one, and then potentially she ends up taking a 3rd free throw. And then from there we can write down the outcome as well as the probability of that outcome occurring. All right, so let's start drawing our branches. So when she begins, she either makes a free throw, M, or she doesn't, which is a D. And then from each of those, then she could either make a free throw or she doesn't. And similarly here, she either makes a free throw, her second one, or she doesn't. But at the very topmost branch, MM, she would be done there. So I'm going to highlight that one. She'd be done because the problem says that she shoots until she makes 2 in a row. And at that point, she would have made 2 in a row. Or the other way she stops is if she shoots 3 free throws. Okay, so all of these other branches, we're going to continue. So from MD, we would draw 2 more branches because either she makes her 3rd or doesn't make the 3rd here as well. Either she makes the 3rd or doesn't make it. Even here, she makes the 3rd or doesn't make it. But now in all of these, we stop because at that point, she's done the 3rd free throw in every scenario. Okay, so the outcomes here, MM, then it's MDM, MDD, DMM, DMD, DDM, and then DD. And now let's put in some probabilities. So let's see. The question says she makes her first free throw 75% of the time. So I'm going to zoom in a little bit. So makes the first free throw 75% of the time, so that is 0.75. That means she misses that free throw, the first one, 25% of the time, so that's 0.25 as a decimal. And then from thereafter it says when she makes a free throw, she will make the next one 80% of the time. So starting at the M, going to the next M, there's a 0.8 chance probability that she makes that next one, which would mean that she misses would be a 0.2% chance, because those got to add up to 1. The question also says that when she misses a free throw, she will miss the next one 55% of the time. So when she doesn't make the first one, she will not make the second one 55% of the time. So this is 0.55, which will mean the one above it is going to be 0.45. So in this way, we can fill out these remaining probabilities. So I'm going to zoom in a little bit more for this. So recall, when she makes the previous free throw, she will make the next one 80% of the time. So this will also be 0.8, which will mean that this is 0.2. Let's write that better. 0.2. And when she doesn't make a free throw, she doesn't make the next one 55% of the time. So this is 0.55, as well as this 0.55, which will mean this is 0.45, as well as this. So now we can multiply these. So this is 0.75 times 0.8. Then we'll have 0.75 times 0.2 times 0.45, and then it's 0.75 times 0.2 times 0.55. All right, so we continue like this. 0.25 times 0.45 times 0.8, 0.25 times 0.45 times 0.2, 0.25 times 0.55 times 0.45, and then 0.25 times 0.55 times 0.55. This is a good chance here, if you didn't quite finish the problem earlier, or you got stuck or weren't totally sure how to begin, to see, can I finish the problem off now that we've talked about so much of it together? Okay, I'm not going to officially say pause the video, but definitely do that if you need to, if you didn't quite finish before. All right, so I'm going to continue talking. So if I multiply these, the first number is 0.6. Then I get 0.0675. The next value is 0.0825, and then it's 0.09, and then it is 0.0225. The last couple have more decimal places. 0.061875 and 0.075625. Alrighty, so let's see if we can write down this conditional probability. So the probability that she doesn't take that third free throw, given that she makes at least one. So using our formula for conditional probability, this is the probability on the numerator that she doesn't take that third free throw. And then we'd write an intersection, which is the word and that she makes at least one. That's on the numerator. On the denominator, it's the probability that she makes at least one. Whatever we are given that goes on the bottom. All right, so let's focus on the numerator first. Probability that she doesn't take the third and that she makes at least one. So I can just think logically about what outcome that refers to. Doesn't take the third and makes at least one. That is the outcome MM. She makes the first two. Let's highlight that. That is this outcome right here, that 0.6. So that is going to be the numerator, 0.6. The denominator is going to be quite big. There's going to be a lot of terms. So the probability that she makes at least one shows up in a bunch of outcomes. That is this outcome, this one, this one, this one, this one, this one. All the outcomes except for the very last one. Alrighty, so we can add up all of those probabilities, which is 0.6 plus 0.0675 plus 0.082. Let's see, let me write this better. 0.0825. And then it's 0.09 plus 0.0225 plus 0.061875. That's what I get on the denominator. If we were to work out what that is, that denominator ends up being 0.924375. Okay, and if I work this out and I round it to 3 decimal places, we get 0.649 for our probability. One quick thing that I want to remark is, there's another way we could have figured out this denominator. This denominator it would have been easier to say that all of these probabilities here, for all the outcomes, they sum to 1. And there's one outcome we're excluding, which is the very bottom one in the denominator. So the denominator is also just 1 minus that last probability, 0.07565. And that would have been a little bit quicker.